Welcome everyone to another great OpenShift Commons briefing. Super excited about this one. I am your host, Karena Angell, one of the OpenShift product managers, and we are here with Austin Dewey and Andrew Block, some of our amazing consultants, and actually they do pretty much everything. So we're here to talk about Quarkus and Helm and how to deploy on OpenShift. And Austin, please take it away.
All right. Hope everyone's having a good morning, afternoon. The quick check, Karena, you can see my screen?
Looks great.
All right. So today we're going to talk about deploying a Quarkus-based app on OpenShift. My name is Austin Dewey, I'm a senior consultant here at Red Hat. I've been working with OpenShift for the past 3 years now. Andy, I don't know if did you want to introduce yourself real quick?
Yeah, sure. My name is Andy Block. I'm a distinguished architect with Red Hat. Been working with customers across the globe for the last 10-ish years, give or take, and really want to talk about Helm and how we can use Helm to deploy Quarkus-based applications.
All right. All right, so if you're here, you probably already have understanding of Quarkus, or you've at least heard of it, but Quarkus is our Kubernetes native Java stack. And some of the features of it here are very low memory usage, very fast boot time and first response time, and very high throughput. And as you can see here, if you're looking real close at this, you can actually see there's a Quarkus plus native and a Quarkus plus JIT. There's two different ways you can actually run a Quarkus app. You can run it in JVM mode, which is where you compile the Quarkus app down into bytecode and just run it on a JVM. This is pretty standard. If you've worked with Java, you're already pretty familiar with how this works. There's also a native flavor as well, which is where you can actually compile the Quarkus app down into a native binary. And depending on the run mode that you choose, it's going to have different implications on how you build that. And if you want to use the native features of OpenShift, if you want to build inside OpenShift, there's going to be different implications on how your build config is created, depending on the run mode that you want to use. So just a quick little refresh, this is kind of a high-level abstraction of how OpenShift build configs work and how you would interact with it to build a Quarkus image. So first, the build config would clone your Git repo. Once that's done behind the scenes, the build config, it actually spawns a builder pod, and it runs your build in a build pod. And then once that's finished, it just ships that off to the internal registry and associates a image stream to that. Now, the challenge here is, okay, so we need a build config. How do we actually configure that build config? There's a few different challenges here, and it actually is going to require both OpenShift and Quarkus expertise. The OpenShift side comes in because you need to know actually how to create that build config, how that, how the YAML is formatted, or what OpenShift commands to run. And the Quarkus side of it comes in because you need to know, okay, well, what S2I builder do I need to use to build my Quarkus app? How should my Docker file be written? And how do I actually create my Docker file to create a efficient build? So, of course, building is only the first part. Once you build that, now you need to think about how you're going to deploy it. And that also is going to require both OpenShift and Quarkus expertise. The OpenShift side comes in because you need to know what are the options that are available to you, right? There's different OpenShift resources. There's deployment, service, config map, and route, and they all serve unique purposes. And the Quarkus side of it comes in because you need to know within those options, what are the best practices? What are the liveness probes that you need to set, resources, all of those things. So there's a lot of different things that you need to consider when trying to build and deploy a Quarkus app into OpenShift. So this is where something like Helm comes in. Helm is known as the Kubernetes package manager. And so you think of something like DNF, right? You would run DNF install, whatever it is that you want to install, apt-get install. Helm falls right in line with that, Helm install. So we're using a Kubernetes package manager to, as we'll get to, install a Quarkus app onto OpenShift. So just a very quick look at Helm. It actually just recently became graduated. It just recently became a graduated CNCF project. So we're very excited about that. It also has a very active community, and I think there's about a handful of maintainers, and they're all very quick to answer questions, close issues, implement new features. It's a very, very fast-moving project. So Helm creates a wrapper around OpenShift resources called charts. And so as we'll see later, it's going to serve as a wrapper around all of those resources required to deploy a Quarkus app. And so, your deployment service, config map, route, and whatever other resources are created, and the user can interact with it with a simple command, helm install. So helm install will create all those resources for you, and you can just kind of sit back and let it do its thing. Helm also allows YAML definitions to be dynamically generated. So what you see here, what I highlighted in red is kind of those dynamic sections. So for example, in a build config, if you want to use a Git source, you probably need to tell it what your URI is, right? Where is it actually going to download that code from? That's something that the user can tell Helm. There's a couple other features here that we'll get to, but the point is that this helps you eliminate as much boilerplate as possible. You don't have to create these resources from scratch. Just tell it what are the important parts here, and it'll go in and actually populate those for you. So users interact with their installation and they configure it using what's called values. So values are just parameters, essentially, but what you do is you create a values file. That's when you go in and you actually create your different parameters. So the build URI, I have my Git repo there, my context stir within that, my build mode, which is really cool. We'll actually get to that one, and then my deployment resources. So I want to give it 2 gigs of memory as a limit, 500 millicore CPU, and then I can just run the Helm install command against that. Run --values.yaml to actually pass in those values, and then I've got 6 different OpenShift resources. They're already configured for me, already dynamically generated and ready to go. So how do you actually interact with these charts? A couple different ways. One is via the Helm CLI, and so you'll just run Helm repo add, and in this case, I'm adding the Red Hat Helm charts repo. And then once you do that, you can install any chart underneath there. So Quarkus, I think there's a Node.js one under there. Helm install Quarkus app, Red Hat charts /Quarkus, and then point it to your values file. And you can also interact with it from the UI as well. All an administrator has to do is create a Helm chart repository resource in OpenShift, and then developers can install any Helm chart from there from the UI. So that's a really cool feature. All right, so introducing, for the very first time, the marriage of Quarkus and Helm, present to you the Quarkus Helm chart. This is a Helm chart that me and Andy have been working very hard on with the Red Hat Runtimes team. We just released our first alpha release, and it is in the Helm chart repository today. So you can actually check this chart out and install it.
And one of the best parts about this is this repository is automatically available inside your OpenShift cluster right now. So if you have an OpenShift cluster and you go to the developer console, perspective I meant, you'll see it there. Check it out, and we'll walk through an example a little later on.
So now I'm going to go over some of the high-level features of this Quarkus chart, and then my friend Andy is actually going to show you some of these features and how they actually work in a live demo. So as I mentioned at the beginning, there's a couple of different ways you can build and run a Quarkus app. There's JVM mode and there's native mode. Well, in the Helm chart, we abstract a lot of this complexity with a single value. It's called build.mode. So I can say my mode is JVM, and if I say that, Helm is going to create basically a S2I build. It's going to handpick the best S2I builder for it, which is probably Java 11 is the one that most people want to use. Of course, you can override that if you want to. And it's going to kick off that build automatically. So it handles a lot of things already for you. If you choose build.mode equals native, then it'll give you a default inline Docker file as an additional build config input. And if you want to override that Docker file, of course you can, but it tries to give you as much as possible by default. So you have to do as little as work as possible. So here's kind of what that looks like in your build config if you choose a native build. I wanted to point out the default Docker file that it uses. So it actually gives you a multi-stage Docker file here. In the mandrill 20 rel 8 image is where it's building your native binary. And then in the second stage, it just copies it over to a UBI minimal image to give you as small of a runtime as possible. Another feature here is externalized application properties. So oftentimes when you're working with Java applications, you have an application properties file. You'd like to externalize that from your app so you don't have to recompile it, between dev, test, prod, and any other stages that you have. Just extract those application properties and you can use the same image throughout all of your stages. The Quarkus Helm chart makes this really easy by using the application properties values. So what it'll do is it'll create a config map with your specified application properties that you set, and it'll automatically create a volume mount on your deployment at deployment/config. So all you have to do is use the values, tell it what your properties are, and it'll automatically create all that configuration behind the scenes. Config change and image change triggers. So this is a really cool feature where as soon as you install the Helm chart, the build will automatically start. So you can get up, go make a snack, go make a cup of coffee. By the time you come back, those pods will be automatically rolled out. So it creates the config change triggers and the image change triggers in these resources for you by default. And one last thing that I want to call out here is freeform fields. As you guys know, there's a lot of different ways that you can configure these OpenShift resources. We don't want to try to box people into a very particular configuration. We want to give people the ability to set things like environment variables, init and extra sidecar containers, liveness and readiness probes, so on and so forth. So we have some what I'd call freeform values that you can actually just pass in verbatim pod templates or volume mounts to configure your application however you see fit. And so the end result here, what you'll see is these 6 resources. So on the build side, you'll see the build config and the image stream. And, again, that gets automatically built as soon as you install the Helm chart. And then once the build is finished, the deployment will spin up and any other resources that are required for your installation are there also. And this can be done with as little as one value here. This is 2 lines of YAML to create an entire Quarkus app. Tell it what your build URI is. It'll go out, clone it, build it, deploy it. And of course, there's several other values that you can use, but we try to provide as many defaults as you can. Just try to bake in those best practices right from the get-go. And if you need to override anything, then of course you can. So one just kind of quick overview of what a Quarkus project might look like that uses this Helm chart. If you want to check these values into Git, what you probably see is maybe some kind of a Helm folder or a .helm folder alongside your application files. So in this case, I have a .helm/values.yaml file. And this is really useful because a CI/CD tool can just pick up this values file and run Helm install over it. So it makes it very easy to integrate with CI/CD tooling. Alternatively, what you can do is you can also just create your values file in OpenShift. You can provide a values file in the UI, and that's what Andy's going to show during his demo. So there's a couple of different ways that you can interact with the Helm chart. A couple of just quick ways to maybe learn more or get started. Just left a couple of different resources here. So the Quarkus guides, there are many different quick starts that the Quarkus team has put together. They're all just awesome quick starts, so I highly recommend checking those out. I also left their GitHub repo, their Zulip chat, so if you have any questions, you can go there, and their YouTube channel as well. They have a lot of great YouTube videos there. And of course, Helm resources. I would be remiss if I didn't plug Learn Helm. This is a book that me and Andy wrote, and it was released earlier this year. You'll learn about all the cool things that I talked about, about Helm, and much more in that book. So definitely recommend checking that out. And if you have any other Helm questions, I left their Slack there, documentation, and some other resources. And so without further ado, Andy's going to show you how to build and deploy a self-healing Quarkus application using the Quarkus Helm chart. Andy, take it away. There, Andy?
I think you're muted, Andy.
All right, let's unmute myself and share my screen. All right, hopefully everyone can see my screen. So as Austin just walked through, we are going to demonstrate how to deploy a simple Quarkus application using a Helm chart. This is a brand new, fresh off-the-shelf OpenShift 4.6 environment, and we're going to demonstrate a lot of the features that are part of OpenShift, including Helm support, as well as the ability to leverage the chart that Austin just walked through. First step we're going to do is we're going to go ahead and just create a brand new project. Just go ahead and call it Quarkus Helm. Just simple stuff. Quarkus as the project name. And there we go. Our goal today is to deploy a simple Helm chart that will leverage one of the Quarkus Quick Start applications. So inside Quarkus, inside the Quarkus GitHub repository, you'll see a slew of Quick Start applications. You can do almost anything in here regarding a lot of the features that come out of the box with Quarkus, as well as enabled through a number of extensions that are part of the Quarkus ecosystem. I decided, because I like to have a little bit of a user interface in most of my demos, to go ahead and leverage the Quarkus Open API Swagger Quick Start. But in addition, I wanted to add a little flair to it, and I added the small RAI extension. So if you go ahead and you use the Quarkus Open API Swagger UI, this is the quick start that kind of walks through how to use the Swagger APIs to deploy a simple microservice using Quarkus. There was a recent blog post that triggered my fancy regarding how to leverage small RAI, a way to enhance your Quarkus applications and other cloud-native applications to add additional metrics and monitoring. And that's basically what I did, is I took this example and then just added the small RAI extension, and away we went. So let's go ahead and let's deploy that into OpenShift. So from the topology, from the list of options on what to deploy in OpenShift, let's go ahead and pick a Helm chart. Makes sense. As I mentioned earlier, these are the out-of-the-box example that come with OpenShift. We're going to be expanding these in future releases, but as you see here at the bottom, we have a brand new Quarkus Helm chart. Let's go ahead and click on Install Helm Chart. First thing we want to do is we want to give it a name. I'm going to cheat here, and I have the name I'm going to choose, which is basically going to be Open API Small RAI. I like to make sure I always have my notes. And by default, the UI is going to populate with a set of default values. If there are certain values that you do need to include, and one of them is the location of the chart or the build URI that you want to deploy. So I am going to go over here and pull in my set of values that will have my customizations. And we're going to notice a few things. We'll kind of walk through this chart as well. On the deploy side, we're going to basically say that we don't want any probes. We don't want to have any liveliness or readiness probes. And then we want to talk about our build side. This is the most important part. Where is our code going to be built from? It's going to be built from my personal repository, which is basically just a fork of the Quarkus Quick Start applications. We're going to reference the Open API Small RAI branch, which is basically just that sample Quarkus application with the additional extension for small RAI. And then we're going to set a couple, at least one environment variable. It's basically going to tell OpenShift, as part of the source to image process, what files we want to include in the deployments directory, so that when we want to start the application, it will have everything it needs to start. And then finally, I did skip over the context directory. Basically, within this repository, which directory has my source code in it. So we have our release name, we have our set of values. Let's go ahead and click on Install. And it's going to go ahead and start up and deploy that Helm chart. And by doing so, you'll see all the different resources that were created. We have a deployment, a build config, a service, an image stream, and a route, so we can access the application. First thing that was triggered was a brand new build. Let's go ahead and click on Build. And we can see we have a running build. Now, for those of you who know Java, you know that when you're building a Java application, it will take a few moments for it to, as I say, download the world. So it's going to basically do a typical Maven-based build for this application. So it will probably take about a minute. While it does that, let's just go ahead and just browse around and see what else it deployed or stood up. What you will notice is that it will go ahead and have an image pull back off. That's because we're leveraging a deployment. And since there is no image that has been built yet, it's going to fail, which is okay. Because if we go back to the Helm chart that we just created, what you will notice is that there's a set of release notes that come with that. So after we deploy the application, if you ever use the command line tool for Helm, you'll notice that whenever you install or upgrade a chart, you might see some additional helper text. This is through what they call release notes. And as you see here, we even call out specifically that your deployments will report this image error pull because it's waiting for a build. Very important. I've had a lot of customers and other individuals who've been working with Helm charts and just OpenShift in general get confused when they're leveraging native deployment resources because it doesn't have that same integrated functionality to wait for the application to be built until it deploys it out. So one of the things to keep in mind. Let's go back to the build again, and we should be able to see that we are able to hopefully finish that build. As you see, the build did complete. We can go back to the Helm, to the topology view. And once it comes up, we should be able to see that application running. As you see, we get the nice, beautiful blue orb. We can go in and click on the URL. We go to the URL, and we get this wonderful application has been deployed. In just a few steps, we're able to get our application deployed and running. And that's great. Perfect. But we didn't really follow best practices when it comes to proper Kubernetes and OpenShift application deployments. You want to know why? Because we didn't set any liveness or readiness probes. If we go back to our application, you'll see that is missing. And that's not good practice. Always make sure you have readiness and liveness probes of some sort so that Kubernetes and OpenShift will know when your application is running or not. This is the pod definition. As you'll see here, there's nothing. There's no way for the application to tell whether it's healthy and running. And that's a problem when it comes to long-living or short-living microservices because in a cloud-native environment, state is not guaranteed. So you always want to make sure you have all the health checks possible. But one of the benefits is that not only does the Helm Quarkus chart support this, but this application also exposes liveness and readiness probes, and that's through that small RAI extension. We go back to the application itself, and we go to /health/ready, i.e., is this application ready to take on traffic? You'll see that it's returning a status up. It is ready. It'll return a 200, and OpenShift will be able to determine that it can start sending traffic to it. Same thing on a liveness probe. We can just go to the /live, and we can say, yep, I'm alive. So we should go ahead and make sure that we don't delete any of the pods because it's unhealthy. It is healthy, and we can go ahead and make sure traffic and application state is still being routed to it. Okay, so we don't have our current chart or current application implementing liveness or readiness probes. How do we do that? Well, let's go ahead and upgrade our application to a new revision. And we can do that all through the developer console. If we go back over here to our Helm release, we can go over here and click on Upgrade, and we can go to my handy dandy cheat sheet, and we can basically tell it to define in our deploy section a set of readiness and liveness probes that use an HTTP GET health check to these different endpoints. We're going to leave everything else the same, and then just go ahead and click on Upgrade, and it's going to roll out that next revision of the upgrade. And through the user interface, you can see all the different revisions and be able to kind of go through and drill down all the different details. And you can even roll back to prior revisions if you want to. A lot of the functionality that you have within the CLI is exposed in the OpenShift Web Console. Going back over now to the topology view, we should be able to see the application deployed again. If we go look at the pod definition, we should be able to see the updated version with the proper checks now in line. As you see here, we have our liveness probe now defined. And scrolling up a little further up, we now have our readiness probe. So we're able to see we are now fully running. The application is not crashing because if it was not probing correctly, the application would start to restart and traffic would not be able to be routed to the application. Just hitting refresh on the page again, you'll see we're still able to hit the application and it's working as expected. Another benefit of the SmallRye extension is it also exposes Prometheus compatible metrics. So if we go over here to the /metrics endpoint, you'll see we're now able to actually get different metrics regarding our application. And OpenShift makes it really easy for you to integrate application metrics into the console so you can start monitoring application metrics quickly and easily. And that's through the use of service monitors, and especially for end users, the end user workload monitoring feature of OpenShift. If you and your cluster administrators have enabled that feature, it makes it very easy for you to go in and be able to monitor your application quickly. And I'm going to show that really fast because that was enabled inside my cluster. So how do we go ahead and monitor my own application I just deployed? Doing so, we'll go into, there is this brand new monitoring tab, well, new-ish, over on the OpenShift side in text review status still, and there's a way to go ahead and grab metrics. You can see a lot of different CPU and a lot of different options out of the box, but we're going to first need to tell OpenShift how to monitor my application. And to do so, as I mentioned previously, we're going to set up this service monitor object. So let me just copy this over, and we can kind of walk through what a service monitor does. First thing we want to do is we want to just give it a name. We'll just call it OpenAPI SmallRye. We then need to tell it which endpoints to go ahead and reach. This is basically what ports, which service port, which scheme, and how often I should go and monitor for the application. And most importantly, based upon the ports that were determined, what pods should I filter on? So of all the pods that are running inside my project, what labels are available and exposed by these pods? And then it will know how to go ahead and reach out to it. So any pod that is matching these labels, app.kubernetes.io/named, and I just say, which is basically my pod name, go ahead and monitor it at the /metrics endpoint. If your application happened to be exposing metrics at a different endpoint, you can customize the service monitor to monitor it differently to a different endpoint. Let's go ahead and click on create. And within 30 seconds, because that's how often I told it to monitor for, we should be able to start looking for metrics inside our monitoring tab. So if we go over here to the monitoring tab, we can go to metrics. We see some base metrics here, but let's go ahead and let's pull one of the metrics that I know is exposed by my application. And you can basically grab any one of these different metrics, and then Prometheus will start collecting it, and then you can start to be able to graph it within the user interface. So I'm going to go ahead back to my handy dandy cheat sheet. That's what I love having to have just in case, because demos are fun, especially live demos. We'll go ahead and grab the amount of heap size that is currently being used by my application. So we can go back over here to the metrics tab, click on custom query. We can go ahead and grab that. You'll see that we can now pull in information. You can see the information started about about a minute ago at 11:29 Central Time. And it will then show this is the pod is running. Just to also demonstrate another pod, if we want to go ahead and show how easy it is to grab another pod in OpenShift, we can go ahead and spin up another pod right now. We go over here to deployments. Go ahead and click the up arrow, and just like that, we'll have a second pod within 30 seconds. It's going to go ahead and be able to spin up a brand new pod. We'll be able to then monitor that within our monitoring dashboard. See if it's gotten a chance to pull that up yet. And it has. You'll see now we have 2 pods that are running. And in a moment, we'll be able to start tracking that and see a comparison between the two. So as you've seen thus far, we've gone ahead and deployed a Quarkus-based application, built it and deployed it using a Helm chart. We've upgraded the chart. We've showed how we can now monitor the application. Now, let's take that one step forward and show, okay, we went ahead and leveraged the out-of-the-box Helm charts, but what happens if you happen to have a Helm chart that extending it to other Helm repositories? Let's just say that you wanted to extend or customize the Quarkus-based chart that your organization might have. Maybe you wanted to take the chart that was provided by out of the box in the OpenShift console and customize it because your organization might have some specific features or customizations that you just couldn't get out of our chart. Let's show how we can leverage the OpenShift console to demonstrate how to extend the functionality of OpenShift by adding a custom Helm repository. To do so, we go ahead and we leverage this wonderful ability to configure custom Helm chart repositories. And it basically says that you create this brand new Helm chart repository object, and then just tell OpenShift where your repository lives. And I'm going to leverage the Red Hat Community of Practice Helm chart repository. The Red Hat Community of Practice, if you're unaware, is a group of individuals within Red Hat that shares great knowledge around, in this example, container knowledge. And Helm obviously being a container technology, we wanted to go ahead and show some charts that the team and the group within Red Hat has had a chance to work on. So to do so, we'll go ahead and we will add this brand new chart repository, which is basically just pulling the chart repository out of GitHub. We can go back over here to our OpenShift console. We can go, once again, import YAML, basically saying we want to import the Red Hat COP chart repository, give it the URL of where my charts are located, and click on Create. We'll give it a moment, and then when it's gotten a chance to pull down the chart, we can go back to the Add button, click on Helm chart, and you'll see that we now have, aside from the out-of-the-box charts that come with the console, all these additional ones like network policy, Jenkins, that are coming from the Red Hat COP. This is just yet another example of how OpenShift really enables you to extend the functionality to suit your own needs. And the ability to leverage custom Helm chart repositories is just one of the customizations that are available in OpenShift. And finally, before I conclude, I wanted to talk about the ability to customize the OpenShift environment. And especially with a lot of my customers, the ability to customize it to suit their own needs is a large, there's a lot of interest around that because it kind of makes developers feel a little bit more at home. It's not just some off-the-shelf product that they went ahead and acquired. They can kind of tune and flavor it. And OpenShift provides many different ways that you can customize the OpenShift console. And to add a little flair to that, the developer tools team is very much interested into how you are going ahead and customizing the OpenShift console. And to do so, we have a little bit of a competition going on. So if you're interested in entering it, you have the ability to win some prizes because, who doesn't love prizes? It's the holiday season, the season of giving. The Red Hat developer team is going to give you the ability to win your own, not only swag, because everyone loves swag, but the ability to even enter and appear on OpenShift TV on a broadcast just like this in the future, actually, like 2 weeks, or actually, pardon me, it's in a week coming up, where you can have a chance to appear on OpenShift TV to showcase the great customizations that you ended up developing. So if you're interested in extending the functionality of OpenShift, I highly recommend you go ahead and check out the features that can be enabled by extending OpenShift, but show us how you customize OpenShift for your own environment. I hope you had a chance to have some fun learning about how to deploy Helm charts on OpenShift, be able to leverage a Helm chart using Quarkus, as well as seeing some of the ways that you can actually use supersonic subatomic Java to quickly and easily spin up a application on OpenShift. Thanks.
Thank you so much, Andy and Austin. I always love your talks, especially, your enthusiasm for the technology, because who doesn't love Quarkus and Helm? I mean, once they get to know it.
Match made in heaven.
It really is. Peanut butter and jelly.
Exactly. So do we have any questions? I did see that Daniel asked if you're using Quarkus 0.0.1. I saw the chart was 0.0.1, but
we are. One thing, because I know actually Daniel pinged me on the side. The one thing you need to make sure that you do is you need to specify the location of the Git repository. He asked, when he tried deploying the chart as it was out of the box, he was getting errors because he didn't specify the actual Git repository of the chart itself. So I'm just going to go share my screen really fast. That was really important. Again, I'll just kind of walk through that. So if we go back over here to the topology view and go to the chart, we should be able to see the sources. I think you can see the different. It may not be exposed in the chart itself, but what we can do is if we go back to the actual values file that was used, you'll see that build.uri. This type of value is required, basically saying, how did I actually build my chart?
And one thing to add, via the CLI, if you try to install the chart without specifying that, it'll actually throw an error and just tell you build.uri is required.
And that's important too, Austin, as you mentioned that, because I think that's what he was running into, is that the console displayed that too. Now, you may be interested, or you may have an existing Quarkus image that was already available. You don't need to build it in OpenShift. There is the functionality within the Helm chart itself to not build an application and just go ahead and leverage one that already exists. So that functionality is there too. So if you have your image like in a image repository like Quay or a corporate repository, you can just quickly and easily deploy from that.
Nice, perfect, thank you. Now, do we have any other questions? Eric, do you have any questions from the live streams? Otherwise,
yep, I just saw one that came in. I'm going to paste it here into the Blue Jeans chat.
Awesome, thanks, Eric. All right, my client wants to start with Quarkus in general. What would be the first step for adaptation, considering they use custom heavyweight runtimes? A good one.
So you're thinking you're coming from a more enterprise application server type deployment, and you want to leverage more of a lightweight microservices with Quarkus? Being able to, that's a bit of a loaded question, only because does the application require a large amount of refactoring? And then what you want to do is once you do that and have an assessment of your application, you want it to use a domain-driven design, determine what your bounded contexts are, determine what can be broken up into smaller chunks, and then from that, go ahead and be able to deploy it. But what I would do is, if you're just getting into Quarkus, start small. Don't try to boil the ocean. Try to take some simple use cases. If you have a simple application in your organization, use that as a first step to get familiar with Quarkus, and then be able to build up from there. Austin, do you have any thoughts?
Yeah, definitely. I would try to consider what your requirements are, because like I said, there's two different ways you can build. You can and run. You can run it in a JVM, or you can run it as a native binary, and they both have kind of their pros and cons. The native binary has a faster startup time and a lower memory usage, but the JVM side has a higher memory usage, a little bit slower startup time, but overall higher throughput. So you kind of have to decide which one is best for you. I would probably start with JVM just to get started, because like Andy said, start small, and I think that JVM is a little bit easier to get started with. That's just my opinion, but you're going to have to make that decision at some point.
Yeah, definitely go ahead and be very agile. Don't go ahead and try to get the small wins. Go ahead and easiest to do is to do the GVM. It's more familiar with you. You'll have less gotchas, and then from there continue to iterate upon that.
So I think it's a good time to also show, I mean, you put it on the resources slide for Quarkus, but this is such a good resource to start coding with Quarkus and going through and being able to pick your extensions and kind of what you want to do. I don't know, do either of you want to talk about this briefly?
Yeah, this is very similar to like the Spring Initializer, if you're familiar with that. It's a very simple, just kind of point and click interface. Tell it what extensions, what dependencies you're interested in, what your requirements are. And once you click generate your application, it'll actually send you a zip file of just kind of a basic skeleton code with a pom.xml there, and some basic skeleton files. It's a really easy way to get started with Quarkus.
That's basically what I use to get started. Even if I already have an application that I know I'm going to develop, I always start with this because it will usually make my life a little easier to get started. It'll have a lot of the features out of the box. I mean, I can go ahead and add that via the CLI, but might as well have it do it for me.
Yeah, it's a really cool tool.
I see it as like a work smarter, not harder kind of thing, and it gets you like 75% of the way there. So may as well use it.
Especially when I work with a lot of my customers, being able to start with that and then fine tune it for the organization will make my life and their lives easier because it gets them quick, bootstrap with their common boilerplates instead of being able to have every developer go in and get almost like a skeleton and then add in all common pieces that every application will have out of the box.
So Daniel sent this over, appreciate it. Now I need to go read it. 4 reasons to try Quarkus. Go download that. We'll add it into the resources slide and post that as well. Awesome. Thanks, Daniel. And more resources. Thank you, Doug. User stories on Quarkus, we'll add those in too. I love user stories. I mean, what's the point if we don't know how to use it or why people are using it, right?
I think it's more of the battle tested, whether it's going to be the lessons learned, the successes, and like all technology, there will be scars. Battle scars are the best kind because you learn the most from them. It makes you a better developer, coder, and just maintainer of the project.
Right, exactly. All right, any other questions? You have the experts here. And are any of you working on some Helm charts and have any questions too? Not just Quarkus related.
Ask us anything.
Yeah, we're very interested in just the Helm experience with OpenShift. We showed off some of the functionality that's part of the product as it is today. How can we make it better? What's working well, what's not working well? We want to hear your feedback because how can we make it better if we don't know? It's like the tree falling in the forest and no one's around. Did it really fall?
Right, exactly. Now, Daniel, I'm definitely going to pick on you because you've been playing with it. As you've been going through it, creating Helm charts or playing with the Helm charts, have you seen anything, any ideas? He's probably slacking you right now. All right. Well, we are looking at more Helm charts for OpenShift. And on the resources page, we had the email address. So feel free to reach out to us at helm@redhat.com if you have any questions on your Helm charts and OpenShift, any ideas. And like Andrew said, what is going well? What could be better? How can we help you deploy your applications to OpenShift and make even better use of all the technology? So.
And we're going to have additional ways that you can interact with the Helm OpenShift team moving forward. So really looking forward to interacting with everyone in the future.
Exactly. All right. Well, if you have any parting thoughts, otherwise, I'm very excited about this presentation. I thank you so much. You two worked really hard on making sure this ran smoothly and putting that Helm chart together. Just awesome. And now everybody can use it.
The demo gods were in our favor today. I'm sure another day they won't be.
Yeah, thanks a lot, everybody. And if you have any questions or just issues that show up with the Helm chart, definitely leave a link on the Red Hat Charts repo. Actually, Karena, I did not include that in the slides, so we want to throw the link to the Red Hat Charts Git repo in there so people can contribute. And
No, you did. You did.
Issues if they need to.
No, you did.
Oh, I did?
Yep.
Oh man.
It wasn't in the resources slide, but you
Great.
did when you introduced the Quarkus chart to begin with.
Oh, good stuff. All right. Awesome.
Yeah. Any pull requests, issues, open source collaboration at its finest.
And thanks for joining us on this holiday week, at least for the US. And we'll be sending these out to the YouTube channel and to the SlideShare. And thank you so much, everybody, for joining us.
Thanks, everyone.
Thanks a lot, guys. Bye.
Bye. And thanks, Eric. Can you see us out?